Modeling reserves with at risk. As a starting point, assume that geological information has determined the following estimates of initial daily production rate per well: Chi, 350 proven barrels, 450 probable barrels, and 700 possible barrels. 1. At range B2:D2 write the respective percentiles that correspond to proved, probable and possible barrels according to SPE's standard, 10%, 50% and 90%. 2. At range B3:D3 write the respective estimated quantities corresponding to proved, probable and possible barrels, 150, 250 and 400. On cell H1 we will insert the distribution function for a typical production well according to the previous information. We know that this should be a log normal distribution. 3. Therefore, click on the Define Distributions icon of at risks ribbon. The following dialog appears. 4. Double-click to select a log normal distribution out of the current common tab. Observe that a log normal distribution required two parameters as shown on the left-hand side parameter tables, with respective values of 10 by default, mu and sigma, or standard deviation. Now, three parameters are provided here by geological information, proved, probable and possible magnitudes, and yet, there is only space for two parameters on a log normal distribution. Fortunately, there is a trick to overcome this. 5. Click on the drop-down button on the Parameters Standard dialog. The next dialog appears. 6. Click on Alternate Parameters and the dialog expands itself for further definition. At the bottom part observe that beyond mu and sigma, there is an additional location or shift parameter that can be optionally used for alternate parameter selection. Alternate parameters allow you to specify values for specific percentiles of an input distribution instead of the traditional arguments used by the distribution. The percentiles to be entered are specified by the alternate distribution parameters options, displayed when alternate parameters is selected at the previous window. 7. Modify the first percentile to 10% and the last percentile to 90%, corresponding to proved and possible percentiles. The intermediate percentile remains as it is at the median value or percentile 50. 8. Click OK to return to the log normal visualization. Notice the parameter section now. Instead of having the two standard parameters for mu and sigma, the parameter table now allows for the insertion of three percentiles, 10%, 50% and 90% respectively. Also notice on top at the cell formula that it contains a reference to a risk log norm alt distribution instead of a risk log norm. 9. Click on the Assign Excel References as Arguments button and make a reference respectively to cells B3, C3 and D3. 10. Click on the upper right-hand corner icon of this dialog to return to the Distributions Definition dialog. The updated curve for a typical production curve should look like this. 11. On the probabilistic bar on top, write a 10% on the left section, and another 10% on the right section. This should respectively move the delimiters to the 10th and 90th percentiles. The curve should now look like this. You could now verify that the 10th percentile corresponds to 150 for proved reserves, the 90th percentile corresponds to 400 of possible reserves, and on the statistics grid you would be able to read that the median and 50th percentile correspond to 250 of probable reserves. A log normal distribution possesses features that make it adequate to reserve estimations. They can only be positive, they extend to infinity on the positive side, and they always show positive asymmetry depending on the standard deviation parameter. Thesis statistical properties match the physical nature of an oil and gas reserve. 12. Exit with OK and now view the distribution function appearing on cell H1. Equals risk log norm alt B2, B3, C2, C3, D2, D3. Excel names have been previously added to many variables on this model. 13. Edit this cell with F2 and replace each one of these reference cells to their names. Observe that the number of parameters on this alternate log normal distribution has duplicated to 6. The first two parameters represent 10% and its respective percentile for proved reserves. The second couple of parameters represent 50% and the median or P50 for probable reserves, whereas the last two parameters are respectively 90% and its respective percentile for possible reserves. The cells should now look like this. Equals risk log norm alt, open parenthesis, perc 10, comma, proven chi, comma, perc 50, comma, probable chi, comma, perc 90, comma, possible chi, close parenthesis. Later on, we will use this typical well initial production variable on the model.